In this short video, we are going to discuss interactive programs and how to work with strings um, rather than with numbers. What is an interactive program? Well, it is a program that asks the user for values, and then the user has to answer so the program can execute the tasks the program needs to do. For example, a program may ask the user for his or her name and greet the person using the name that was typed in. Just like when we log on to a service like Amazon, we normally see, Gabriela, these are the suggestions for you. That's what I would see. So that's an example of an interactive program because we typed in the username and the password, and then the program that we're running digs into the database for our name and greets us using our name. Our programs in this class are going to be much simpler than that. We're going to be able to prompt the user for their name and then say, hi, Jonathan, hi, Mary, and so on. Another example would be a program that may need the user to type in how many coins they have collected to let the user know how many dollars and cents those coins represent. So rather than having the value of the number of coins that we have collected in a piggy bank, we may use the program so different people can run it with different values. So that would be an example of an application, right? You have an app, the person wants to find out how many dollars the 3,055 pennies represent. And they type that in, and then the program runs and lets them know the dollar amount of those coins. Another example in this slide would be an employee may type how many hours the person has worked for the week, and then the program will calculate their weekly pay using that value. So these are some examples in which a program may need information from the user to run and give results to the user. Okay, so how do we do it in the language that we're learning this semester? We say that the program needs to prompt the user. So whenever we say prompt the user for such and such value, what we mean is that we want the program to ask the user for a certain value. So the program is going to show up on the screen and it's going to say something like, what is your name? Like we see on this Python screen. And the program will hang in there. It's not going to keep going until the user answers the question somehow and presses the enter key. In reality, what makes it keep going is the enter key. You can type in a zillion names, but if you don't press the enter key, nothing will happen. And you can leave it blank, and as long as you use the enter key, it will move on to the next task that was spelled out in the program. So in this example, I typed in my short name, Gabby, and then, of course, because I wrote this program, I wanted the program to tell me something nice, and it says, Gabby, you're a genius. So after the execution, we know this program has finished because we see the Python prompt on the screen. So we're going to have to practice using a new line of code. The line of code that I have used in the full program to get the input will be name is the name of the variable, equals, input is the command, and in parentheses you need a string that represents a question. So inside the parentheses you have what is called the prompt. Whatever is in parentheses is what is going to show up on the screen. So it's similar to the print command, but we not only want to display this, we also want to accept the input. So rather than saying print, we say input. And And then in parentheses, you have your question. And when the person presses enter, that value needs to be stored somewhere. So in this programming language that we're learning, everything happens in a single line, but there are two actions that are happening. We display the question with input blah, 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 blah. And when the person presses enter, that value gets stored in whatever variable you have listed on the left. So we say that we prompt the user in an assignment statement. So to get input from the user, two things are done. The prompt needs to appear as an argument for the input method. When you have a method that needs something inside the parentheses, that something that goes inside the parentheses has a technical term that is called argument. It's good to get used to this terminology because in the future you are going to write your own methods. And depending on what the method does, sometimes it needs something in parentheses and other times it needs nothing in parentheses. So when we want to get a value from the user, we need the prompt as an argument in the input method. And the second thing that needs to happen is that the value needs to be assigned to a variable. So what I was telling you earlier, we need to spell this out in an assignment statement. So we have a variable name equals input, open parentheses, whatever question you want to ask, and it's a string literal, so you need to surround it by single quotes. Now, something that is tricky about this process is that in Python, when the value is accepted into the variable, it will always be a string data type. Even if the person types in a number like the number of coins, so 355 coins, well, even if they spell that out, it is accepted as a string. We know by now that strings can have any mixture of characters. It can be letters, it can be symbols, and it can also be digits. So something like a zip code, we will want it to be a string. But something like the number of coins in a piggy bank that we need to convert into dollars and cents, we do not want it to be a string. We would like it to be a numeric data type. So what do we do if we would like to accept numbers from the user, meaning that we want to use them as numbers? We will learn how to do that in the future. So this is what our textbook says. Python 3, which is the version we're using, has a function named input that can be used to get input directly from the user. It takes the string as an argument and displays it as a prompt in the shell. It then waits for the user to type something, followed by hitting the enter key. The line typed by the user is treated as a string and becomes the value returned by the function. So look at the code. Name equals input, enter your name. So enter your name is the argument of the input method, and it is assigned to the variable name. So what's going to happen is that we're going to see the outcome of that line of code is enter your name, colon, and then the person has typed in George Washington and pressed enter. Okay? And then the next line of code, print, are you really, comma, so string literal, are you really, and then the variable name, and question mark. So notice the separation of the three parts of the statement because it's a question. So it's going to display, are you really George Washington? Because the person typed in George Washington, then that George Washington was assigned to the variable that has the name, and then the variable name is used for the output. All right. So let's start practicing together. I'm not going to be coding in NetBeans and in Python, but you are going to pause this and you're going to type this code in. So what you want to do is have the comments, but notice that this program's algorithm has only two sections, get input and the output. So we accept input from the user and we display an output statement using the input from the user. So we have 3 lines of code in getting the input, so we're getting 3 values from the user. Name equals input in parentheses, what is your name? And then next line, color equals input, what is your favorite color? Next line of code, pet equals input, what is your favorite animal? So we're asking the user, we did something similar in the past, but you hard-coded those values. Now we are making this program interactive. So we're asking the user for these 3 values, and we store them into the variables name, color, and pet. And then in the output, we can use those variable names, and whatever the user has typed in is what's going to show up in the output. When you copy this code, notice in the last line of code that I have a contraction, wouldn't, so I need to use an escape sequence. So we're not forgetting what we learned so far. We continue to use what we have learned. So code that, and when you're done, take a screenshot, put it in a Word document. This is Practice with Me, week 4. The topic is interactive programs. Put your name in Python, and this is exercise number 1. So in the Word document, put a title for exercise number 1, and this is your first interactive program. Good luck. And then you run it. When you run it, don't forget that you're going to type in the information and press enter. So when you run the program, this is what's going to happen. The question for your name is going to pop up. You need to type in your name and press enter. Once you press enter, the next prompt is going to show up. What is your favorite color? And once you answer, then the next question is going to show up. So the next question is, what is your favorite animal? So I have answered using my dog's name, Kahana, the favorite color pink, and then the animal is a dolphin. So then the output would read something like this with your personal information. Kahana, wouldn't it be cool to have a pink dolphin pet? So please, you use your own ideas of names, color, and animal. So we know the program finished its execution because we see the shell prompt, which is those 3 greater than symbols. And then make sure you type the title exercise 1 in a running Word document where you're going to insert all the screenshots. So for this one, insert both screenshots, the one for the code and the one for the output. And I think the lines of code may be becoming a little too wide, so you can have the code above the output. So once again, let's practice a different exercise with different variables. So this is going to be your exercise 2 for your output, for your running document. So change the comments at the top. This is exercise number 2. And what this program is going to do is going to ask for a person's name, GPA, and age to the user. And all the values will be string data types in this program. So when the person answers and it gets stored, it doesn't matter what characteristic those characters have, they're all string. So to get input, now we're going to ask for the name, the age, and the GPA. So we change the names of those variables, and notice that the structure of the statement is always the same. Variable name equals input and the question in parentheses, the prompt in parentheses. So name equals input, what is your name? So you can edit the same program, but remember, save as, and then put exercise 2. That way, in the future, if I ask you to, or invite you to recycle a program we have used, you have that available. So name equals input, what is your name? Question mark, close, close. Next line, age equals input, what is your age? Close, close. GPA equals input, parentheses, what is your current GPA? String literal, close parentheses. And then in the output section, age, so the name of the variable, comma, the string literal, years old, student name, and then close single quote, comma, the variable name, comma, single quote, currently holds a, single quote, comma, GPA, comma, and then you can capitalize GPA all uppercase because that's output to the screen is a string literal, so it doesn't matter. So what's happening is that in this case, our program does not need to do math with those values that look like numbers. So we don't have to worry and we don't have to do anything to convert them from string to numeric types. Soon we're going to see how we can convert from string to numeric so we can do math with the values that the person inputs. So let's run this program and answer each question as it pops up on the screen and finish running it and take the screenshots. So in my case, I kept using Kahana's name and then I said that she's 22 and the current GPA is 4.0, of course. I cannot have anybody that is not very smart around me. That's not true. So it would say 22 years old student named Kahana currently holds a 4.0 GPA. Kind of sounds like a headline. Take the screenshots, insert them in your Word document under the title Exercise 2, and we'll move on to the next. So if we were to check, do you remember that we have a command that is type? If we were to check what type the input is, it's going to tell us that the type is string for any input that the person has entered. So this is a comment that is in our textbook. So what happens is that if we try to multiply a string, interesting enough, what happens is that if you have the value 3 in the variable named n, if you multiply it by 4, it's going to show you 4 times the digit 3 rather than the result of the number 3 times 4, which is 12. So if we needed to do math, we're going to need to do something with that number. So let's edit the example that we just did and add a calculation to confirm that they're strings. So let's see. So let's add a variable in the declaration. So this is going to be your exercise 3. So, but you added the exercise 2, right? So this is exercise 3, and this program asks for the name, GPA, and age to the user. Since user input is string type, multiplying it by a number, it repeats the value that many times rather than calculating the result of the mathematical calculation. So this is what we want to demonstrate here, how it works, because the input from the user is a string. So we're going to add a factor equal 4 in the declaration, which is what we're going to use in the multiplication. I recommend, remember that you always use variable names as much as possible in the calculations, That way, if you need to change a value, you just change it in the declaration, and the multiplications, in this case, they would get adjusted automatically to the new value. All right, so declare factor and initialize it to the value 4, and then we still have the same code in the get input section. What's going to change is the output. We're going to add, after the long output statement, we add 2 short lines, and we say print age asterisk factor, so age times factor, and print GPA times factor. So we would expect those to be numeric values and see results. So let's see what happens when we do that. So with our own example, add those 2 lines of code and then run it. So when we run it, it's very peculiar. In my case, what is your name? Tim. What is your age? 23. What is your current GPA? 3.75. And if you remember, my output said display all the information like before, and then display the value that was entered times 4. So what we see is 23232323. So that's very confusing, but we know that the factor had the value 4 and we enter the number 23. So that means that 23 will spell out 4 consecutive times. And then the GPA is 375, and it looks weird because all the numbers are bunched up together. It kind of looks like an IP address, but in reality what that is 375, 375, 375, 375. So the value is 375 that was entered by the user spell out 4 times. So we would expect to see the result of a multiplication, but we see strings repeated as many times as the factor says. So you're probably intrigued by now, hopefully, if I inspire you to think in that direction. So you may be intrigued, how can we modify the input so it becomes a numeric value? We're going to see that now. There's something that we call cast operators. In some places you may see it expressed as typecasting, and in our textbook they call it type conversions. So type conversions, also called typecasts, are used often in Python code. We use the name of a type, so you're gonna use the name of the type as if it were a command. So you're going to use the name of a type to convert values to that type. So for example, the value of int single quote 3 single quote times 4 is going to be 12. Why is that? Because you have the word int in front of the string literal 3. You're converting the 3 to an integer, and you multiply that integer 3 by 4, and it will give you 12 rather than the character 3 4 times. When a float is converted to an int, the number is truncated, not rounded. So the value of int, get the int of 3.9 is going to be the integer 3. All right, so that's something else that we need to remember. So the type conversion is not only for the example that we're working on. Right now we're working on converting from a string to a numeric type. So what numeric types do we know? Int and float. But also we can use an int in front of a float to convert the float to an int, and it will truncate it. And you can do the other way around. You can convert an int to a float by putting the word float in front of an int, and it will say 0.0. Here are some examples, and I think that we need to test one because I think they made a mistake. So we have a list of examples. This is from another textbook, and it says the int of 4.8 gives you 4, and I believe the int of negative 4.8, it should be negative 4. So we need to test that. And then we have the int of 4 is 4. And then we have the float of 4.67. That's going to be 4.67. The float of negative 4 is going to be negative 4.0. So it's adding the decimals to an integer. And the float of 0 is going to be 0.0. So there you have 3 examples of each one of the conversions of one data type to the other. So let's edit our program in IDO editor by adding typecasting operators. And when you're done, take a screenshot and insert it in your Word document under the title Exercise 3. So in our code to add the typecasting, we just need to add 2 lines of code only. So we're going to in the algorithm, we're going to add the process section. So far, we only had a declaration, we were getting input, and we were displaying the output. Now we're going to convert from one data type to another one. So we're going to say that we're doing that in the process. So we add the process section in the algorithm as a comment line, and there are only 2 new lines of code. And what we're trying to do is the age is normally given to us as a whole number, right? So whatever the person types in, like I would type in 57, then that is going to be converted to int, right? So we're going to say the age that was typed in as a string, now we're going to change it to an int. So in the same variable where we held the input from the user, we're going to override it with the integer version of what the person typed in. So age equals int. So remember, this is as if int was a command, so or a method. So we say int, and then in parentheses we put the argument. What do we want to convert to an integer? The age that the guy typed in. Remember that this is an assignment statement. It works from right to left. So the age that is on the right is the one that the guy typed in, that is a string. It gets converted to an integer, and then it gets stored in the same variable. And then in the next line, we're converting the input from the user to a float. So the GPA is going to receive the conversion to a float of the inputted GPA. So we're typecasting strings to the first one to an integer type and the second one to a float type. And then we don't have to modify anything else because we still want to prove that now we can do math, that the operator asterisk is going to produce the result of a multiplication now, because now age and GPA have been successfully converted to an integer and a float respectively. So run this program and see what happens. So in my case, I typed in the name Florence, and then for the age, I typed in 15, and the current GPA, I kept it as 3.75 like before. So now the sentence remains the same, and then the calculations get performed. So what is in that magenta box, 60 and 15.0, are the results of the calculations of 15 times 4 is 60, and 3.75 times 4 is 15. And because it is a float, it shows me 0.0, even though it doesn't have any decimal component. So now the multiplication gives us the result of multiplying each number typed by the user by the factor we set in the program. So you can run it again on your own and you can change the value of the factor and you can see that the multiplications give you different results. So to be able to perform calculations using a numeric value entered by the user, we need to use typecasting, which means the input is a string, we need to convert it to an int or a float. Now that you have done this work, take screenshots of the both parts that you have done, the code and the output screen, and put them in your Word document under the title Exercise 3. In another textbook, I have seen that we can combine rather than break it up into two parts. This is how you can do it all at once. If you know ahead of time that you want the integer of the input, this is how you can nest one method inside another one. So age equals the integer of the input from the user, enter your age. Age, or alternatively, age equals the float of the input of what the person enters. So this is how you can compress the two actions that we need to perform to get numeric input from the user. For the time being, I prefer that you use the style that I have shown you in the exercise that you share with me, just so you demonstrate that you understand what's going on. But some of you have been doing programming for a while, so if you feel more comfortable doing this, go ahead. You're allowed. So finally for today, I told you that we were also going to see how we can work with strings. There are multiple things that we might want to do, and in the future we're going to learn a little bit more about working with strings. So for the time being, I got this table from another textbook, and it shows a list of methods that we can use and how we verbalize them. So let's see. The first one is the only one that is different from the others. So LEN stands for length. So oftentimes we want to know how many characters a string has. So we need to assign that value to an integer variable because the number of characters in a string is a numeric value of integer type. You know, somebody's name has 5 characters. A password needs to have 8 characters at least. So you would count to validate that the person has typed in a password that is legitimate. You would count that the password has at least 8. So oftentimes we want to find out the length of a string, and we do it by using the method. These are all methods, so these are instructions that have been coded into Python, and we can use them when we have variables that are string data type. So we can find out how many characters long a string is, and we are going to assign that to a numeric variable. So you would have something like how many equals len parentheses name close parentheses. Okay. They're using the example str1 equals Python. It says there in the title. So if you have the value str, if you have the word Python in the variable name str1, then the value is going to be 6 because there's 6 letters in the word Python. Okay, so you need to store that into an integer variable because the result of executing that method is an integer. And then all the others are going to give you a string. So the only one that is a little different is the first one. So upper converts the string that you have at hand to uppercase. You always need to store it into a variable. So all of this will be in an assignment statement. So to the right of the equal sign, you will read what it says in the example. str1 dot upper open and close parentheses. So nothing goes in the parentheses of this. So upper is a method that is applied to the object of string data type. So the syntax is the name of the variable that is string data type dot upper open and close parentheses. And the outcome is going to be that is going to give you a string all in caps. You can do the opposite. Sometimes we may want to make sure that the word that is in a certain variable is in lowercase. So we have the method named lower, and we would say the name of the variable that is string dot lower open and close parentheses, nothing in parentheses. So this will be assigned to a variable that is string data type. Count. Count is also, my bad, this is also a method that is going to give you a number as the result. So what this does, it counts how many instances of whatever pattern of a string, substring you type in surrounded by single quote in the parentheses. So it could be a letter also. So my example counts how many times the letter T shows up in a sentence. So we're going to see how to use that. Capitalize, well, it's exactly what it says. It capitalizes whatever the string is. Title is the title capitalization, so it capitalizes each word that appears after a space. And then strip, it gets rid of a space. Sometimes when you have a data file, you want to make sure that you get rid of all the spaces that you have accidentally between words, because normally there is a separator for the different parts of information that is in a data file. So you may need to get rid of all the spaces, and that's how it's done. So we're going to practice a few of these commands with an example. So this will be our fourth and last exercise for this practice with me. So exercise 4, this program prompts the user for a sentence and uses string methods to work with the string. So we're going to have 3 parts of the algorithm. We're going to get input, we're going to process the input with these methods that we're learning, and we're going to have not output, but output. I just noticed my typo. Okay, so print. So a lot of times we want to make the program a little more user-friendly, and we tell the program we either welcome the user, or we may want to show some information on the screen that tells the user what the program will do. So print, I will ask you to give me a sentence, then I'll do something with it. So there is a contraction there. So again, we're using an escape sequence. And now the prompt, sentence equals input, type any sentence. Okay, so in the process, we're going to use these methods that are in the table. So T equals sentence dot count T surrounded by single quotes. So this statement is going to count how many times the letter T appears in the sentence that the person types. Upper equals sentence dot upper, nothing in parentheses. This statement is going to convert the sentence to all caps, and is going to store it in that variable named upper that it was just declared. Title equals sentence dot title. This, don't forget the open and close parentheses. So this is going to use the title capitalization on the sentence, and is going to store it into the variable named title. And then the last processing statement that we have is how many chars equals len sentence. So what it does is going to count the number of characters, and that includes spaces. They're going to be counted, how many characters letters, symbols, digits, and spaces are in that sentence the person types in. So the output is going to be something related to what we have just done. So 4 output statements because we're finding out 4 different things. So the letter T shows up, comma, T's is the name of the variable that holds how many times the letter T shows up, and then types in your sentence. So watch for the details of the syntax of that statement. Something similar for the capitalization version. So your sentence in all caps, comma, upper, the name of the variable that holds the uppercase version of the sentence. Print your sentence as a title, comma, title. So we're going to see the sentence in title capitalization. So each new word is capitalized. And finally, print your sentences, how many characters long. So it's going to tell the count of characters. So when we run the program with any sentence, so I write a sentence, you guys write any sentence that you want. So this is what I have done. When I run the program, the directives or the user-friendliness sentence shows up. I will ask you to give me a sentence, then I'll do something with it, and then it goes to the next line and it says type any sentence, and then this is what I typed in. So it appears in a different color, right? So my dog and 2 cats are 3 spoiled pets. As you can hear my dog in the background, I think. So when you press enter, then all the processing statements will execute, and then the output statements will execute one at a time. And it's going to say the letter T shows up 4 times in your sentence in all caps, and it shows the same sentence but in all uppercase. Your sentence as a title, and now notice that each letter is capitalized, and then it tells me how many characters long the sentence is, and I counted one by one my sentence between letters, the period, and the spaces. They count to 43. So once that you're done with your own sentence, you don't have to spell out my own sentence. Practice with multiple sentences, and if you practice different things, paste different outputs to the screen, and when you're done, save it as a PDF file and upload it as the Practice with Me exercise for week number 4 in Blackboard. Thank you. I'll see you in class.